Hi, my name is Arnold Nordeng, and I am a design engineer in the Signal Conditioning Business Unit. Today, I am talking about an op-amp that I designed, the LT6016. The LT6016 is a dual amplifier with a supply range that spans 3 volts to 50 volts. It features less than 50 microvolts of offset voltage, under 5 nanoamps of input bias current, and runs off 320 microamps per amplifier, has low 1/F noise, and is housed in a small 8-pin MSOP package, which is specified from -55 degrees C to 150 degrees C. But what really makes this part unique is that it combines these good precision specifications with some very interesting protection features. These protection features that I will describe are meant to make the op-amp really useful in demanding, rugged environments where the inputs, outputs, or supply pins of the op-amp are exposed to sometimes extreme abuse. First, let's take a look at the input protection of the LT6016. You can actually take the input pins of this op-amp to as high as 80 volts above the negative supply, regardless of what voltage is applied to the positive supply. For example, the op-amp could be powered from 0 and 5 volts. 80 volts can be applied to the inputs, and that's perfectly okay. Most other op-amps have internal diodes from their inputs to the positive supply, which turn on when you do this, drawing unlimited input current until either the input source is dragged down or the op-amp blows up, whichever comes first. But the LT6016 is very tolerant of this condition, drawing at most microamps of current. In fact, the inputs are not only protected with 80 volts applied, but will actually operate at 80 volts. This means that nothing gets damaged and the source driving the inputs is not loaded. This feature is useful, for example, if an op-amp sitting at the front end of a circuit board is driven through a cable or a connector from another circuit board. And let's say that the board with this op-amp is not powered up yet, but the other board that's driving it is already powered on. In this condition, you don't want your circuit board's input op-amp to be destroyed, and you also do not want to disturb the board that's interfaced to it. The LT6016 is perfect for such situations because the inputs will draw almost no current, even with voltages applied that are up to 80 volts. In addition to taking the inputs above the power supply, you can also yank the input pins of this op-amp apart by as much as 80 volts. Again, no damage or loading of the applied source occurs because no excessive currents flow. The inputs of the LT6016 are designed to tolerate this condition. Many other op-amps have diodes across their inputs which turn on, which will be damaged if excessive current flows. The final input protection feature that I want to describe is the ability to take the inputs of the LT6016 below the negative supply by as much as 25 volts. In this case, some current will flow, but is limited by an internal 1K ohm resistor. That's certainly much better than unlimited diode current, and it will not damage the op-amp. So with the input pin protection in mind, I'd like to show some practical applications in which the LT6016 op-amp should prove really useful. The first application example is low-side current sensing. This is when you place a small sense resistor between the load and ground and use an op-amp to amplify the voltage across the sense resistor, which is proportional to the current that flows through the load. Because the LT6016 op-amp inputs operate down to ground with good accuracy and low noise, it is a great amplifier for this kind of application. Now let's say that you want to make the system really fail-safe. Let's think about what happens when this ground connection breaks. The entire op-amp input stage would get pulled up all the way to the battery voltage, which, for example, in automotive systems could be very high. So you can see how many other op-amps would be damaged under those conditions. But the LT6016 allows the inputs to be pulled far above the supply and will tolerate this just fine. You could also imagine what happens when the sense resistor fails open. The op-amp inputs will be pulled apart to the battery voltage, which again requires the unique kind of input protection feature that the LT6016 offers. Another thing that you can do with the LT6016 in such a current sense circuit is to actually power the op-amp directly from the unregulated battery voltage. Since the supply is protected up to 60 volts absolute maximum, as well as -50 volt reverse bias, it should survive even the most stringent battery conditions, such as automotive load dump and reverse battery connection. The last application circuit I want to show is that of a difference amplifier designed to measure ± 10 volt input voltages, which is the typical output range for many industrial sensor modules. By connecting the 4 resistors around the LT6016 op-amp as shown, you adapt the ± 10 volt input voltage to a low voltage output, for example, to be digitized by a modern ADC on a 5 volt reference. Now, if you use the LT6016 op-amp for this circuit, with the ability to operate its inputs far above and below the op-amp supply rails, you can actually work out that the inputs to these resistors can be taken to more than ± 350 volt common mode or differential mode. That means that it is perfectly safe to connect a cable to the circuit that may pick up all sorts of noise, and the LT6016 input op-amp will survive. What is especially unique is that this works while the LT6016 is powered from quite low supply voltages, which in turn is handy to ensure that sensitive ADC circuitry that follows it cannot get damaged, no matter what abuse comes in at the inputs to the board. In summary, the LT6016 is an op-amp that for the first time combines excellent precision specs, such as low offset voltage, low bias current, and low noise with unique protection features at the input pins of the op-amp. This allows you to use this op-amp in many applications where you have to make precise readings in the presence of rugged and uncertain environments. For more information about the LT6016 and to learn about some of the other great features of this product, please visit linear.com.